Finding the RPM, gallons per hour, and true airspeed is a relatively simple task. Now that we have found the pressure altitude, we can refer to our POH and look for the cruise performance chart. Using this chart, we want to take a look at the conditions noted at the top. The assumption is that the aircraft is flown at a gross weight of 2,300 pounds and the mixture is lean as per the manufacturer's recommendations. If you are lighter, you will see better performance. If you do not lean the mixture as per the manufacturer recommendation, then your performance and fuel burn will be different as well. We enter the chart on the left at the pressure altitude window we intend to fly at. Wait, we only found the pressure altitude for the airport. What do we use for our en route pressure? Well, your best judgment is okay here. In our case, the pressure difference between Red Deer and Calgary is 0.01. We can simply use the Springbank altimeter to find our pressure altitude. So 29.92 minus 3000 equals minus 0.08. Multiply that by 1000 and we get minus 80. So our cruise altitude of 7,500 feet minus 80 equals 7,420 feet. We can round this number to 7,400 feet. When looking at the chart, we see that we cannot enter at 7,400 feet. We can't even enter at 7,500 feet. We could interpolate between the 6,000 foot and the 8,000 foot level, but you will notice that these numbers aren't really that different. Since we are closest to 8,000 feet, we will use the 8,000 foot numbers. We will enter the chart from the left at the 8,000 foot level and use 2,300 RPM. We have chosen this number because it gives us a reasonable speed and fuel burn. To determine which temperature column to use, we need to know what standard temperature is at 7,500 feet. Remember, the temperature drops by 2 degrees per 1,000 feet as per standard lapse rate. At sea level, the standard temperature is 15 degrees. 7,500 feet higher with a 2-degree lapse rate gives us a standard temperature of 0 degrees. Since the upper wind chart told us the temperature at our cruising altitude of 7,500 feet was minus 5 degrees, we are closest to standard temperature rather than 20 degrees below. Should we interpolate between temperature ranges? Well, if we look at this chart, we see there really isn't much of a difference. Being only 5 degrees away from the standard temperature, we will just use that column. As we work our way over to the standard temperature column, we find percentage brake horsepower, which we won't be using today. Our true airspeed reads 103 knots, and our gallons per hour reads 6.0. We can now record those numbers into your nav log.